Greetings, Chem 110B, Dr. Bevilacqua here. I want to go through dihedral angles, in particular also as they relate to phi psi. I've had a lot of questions about these, and also there was a mix-up on the slides, and I want to make sure that that gets completely cleared up. And so I'm going to take you through something related to, but slightly different from what was in near the end of the last recitation. So I have up on my screen here the alpha helix scene, and I made the background black because it's going to be easier to see the dihedral angles this way. And so I'm going to measure some different dihedral angles so you can see the alpha helix, just to remind ourselves that if I tip this guy, the ribbon that you see is along the main chain. So ribbons, cartoon diagrams, they always trace out the main chain that you see here. And the side chains, they come out away from the main chain. So I want to measure some dihedrals, and it's a lot easier to do this if we go in and we hide the main chain. Sorry, if we hide the ribbon. So I'm going to just go up and do that. Hide cartoon. Okay. So so I'm going to go in and I can see that this is the carboxy terminus. And then up over here on the right are the slides, the corrected slides. And the first thing I'm going to do is measure the omega dihedral. And I want to remind you that dihedral angles always consist of 4 different atoms. And so I'm going to go ahead and find the peptide bond, and it's right there. It's between the it's an amide bond. It's between the NH and the C double bond O. And I can actually go on here and emphasize this for you guys. So here's the peptide bond right there. And but I need 4 atoms in order to measure that. So I'm going to need to go one before and also one after, like that. Okay, so let's go back and then we can go ahead and measure this. I've got my measurement set up for dihedrals. I want to measure the dihedral angle about this bond, and so I'm going to click the carbon before, the N, the CO, and then over here the C alpha, and that's going to give me the angle, and it's kind of hidden back in there, and I can go back and find it. There it is. It's 179.4. Okay, or about 180 degrees, meaning that the C alphas are trans with respect to that peptide bond, and I can see that. So if I turn this guy so that I'm looking right along atoms 2 and 3, then I can look at the alpha before and the alpha after, and I can kind of see that they're pretty much at 180 degrees if I look at this guy with respect to that guy. And that's what we expect. And over here on the right, that's the omega. And that's what I'm looking at is the angle sighting along this bond between this alpha. And that omega is typically 180 degrees. It's typically trans to avoid steric clashes, although we've seen some exceptions. All right, so let's move one more along the peptide bond. I'm going to do psi. This is going to be between the carbonyl C alpha and the carbonyl and the C alpha. So so this is psi, so I need to back up one before that bond to the NH, and so I'm going to start here, and I'm going to go 1, 2, 3, 4. And when I do that, I can see that the angle is minus 54.9, and that's for psi. Okay, and then I can continue and I can advance one more position in order to get phi. This phi is between the C alpha and the nitrogen, and here's the C alpha and the nitrogen, so I start one before that. 1, 2, 3, 4. And that gives me that other number that's tucked way back there. There it is, minus 79.8. I'll call it minus 80. So try this, okay? You guys pull this up if you didn't finish the recitation, and do the one that you're supposed to do, which is aspartate, and make sure you can get the right angles. But that defines omega, psi, and phi. And then what I can do is actually plot these on a Ramachandran plot. So if I go to the notes here, here's a Ramachandran. And the values that I have are psi turned out to be equal to minus 54.9, call it minus 55 degrees, and phi turned out to be minus 80. And so let's see if I can find those. Psi of minus 55, so there's minus 90, minus 45, minus 55 is like right about, say, here. And minus 80 on phi, here's minus 90, so minus 80 is like right about there. And if I go up and I find those two guys intersect right about there. So that's where that point is. And you can see it's in a nice black area. It's not an unexpected psi-phi combination. So hopefully this helps you to think about what dihedral angles are and how they relate to the Ramachandran plot. Go in, and if you didn't do that last problem on the recitation, now's a good time to practice it on your own. Thanks for watching.